So, quick round of introduction, and I got an introduction from you. Yeah. Now, my introduction, my name is Parichay Banerjee. I work with ING, Java backend engineer, and I live in a place called New York with my family. I'm from India, and then social media for connections. So in this talk, I'm going to focus on three key principles or points for unit testing. In Java, it could be Java, but it's in general. Randomness, repetition, and corner cases. So these are the three main topics that we are going to talk about. And we are going to see in next few minutes what are the limitations of what we have been doing traditionally with static, manual, hard-coded data. What are the benefits you could get if you start using, if you are not already, libraries for generating those test data? What are the tools, libraries, when to use what, etc. Those use cases we will be talking. But before talking about the solution, let's talk about the problem and what we are doing. 2006, I found this blog post. It was written in 2006 by Martin Fowler. It talks about a pattern that emerged in ThoughtWorks, and it's thereafter has been used in many different forms and shapes. But essentially, what it allows you is you create a structure of an object, and then you create variations. And in different applications, you would be doing it differently, but essentially, when the application grows with complexity, you add builders, factories, and so on to manage the complexity. With J-Units, you have more flexibility to add annotations, use CSVs, value sources, and so on. Those are the use cases, or the way that we use with different kind of testing data. That's fine. But then it also can be, it also has some drawbacks or downsides. I like the way it's grouped together as an example-based testing. Because what you are essentially doing with all those examples is you are creating a set of data. You start with an example, and then there's a target function or method or service that you test with, right? Now, example-based testing has its limitations. The first one I want to talk about is pesticide paradox. What pesticide paradox does is it creates immunity of the bugs. So that means if you keep on testing the function, the target, with the same data over again, given that your function evolves, your code evolves, if you do not change it, the bugs gets hidden. That's one of the problems. Another problem that I found myself, probably you all know it in different names, but the concept is important, not the name. I call it a Fuber syndrome. Maybe you have done this, or you have seen this other doing it. Test 1, 2, 3, test 1, 2, 3, 4, test 1, 2, 3, 4, 5, and so on. So this kind of naming you create in the example-based testing, and what happens is it creates smell in the code, which becomes not so nicely maintainable in the longer terms. There are more limitations. I have listed some, but probably if I ask you, you can say some more, you can say some more. Point is, hard-coded and manually written data has its limitations. And the benefits could be that when you remove the staticness, you add randomness, you add more range and scope, something which is called monkey testing. You add randomness. So that solves the pesticide paradox that I talked about. When you add corner cases, edge cases, with a library, that means, because for example, if I tell you how many times you add the maximum possible integer in consideration for your test, you would be rarely doing this because it's so verbose and so difficult to do that all across your source code, right? So if we can give that work to the libraries. That's wonderful, right? Let's take another example. Suppose you are creating a application which is specifically designed for the customers of Netherlands or Germany, and you want to have real data to be used. For example, addresses, IBANs, phone numbers from those locale specific. What about those locale specific data? How do you create and maintain? And of course, the last two things that I like the most, fewer lines of code that you write, the boilerplate goes away, and then it's more clean, readable. So I'm going to introduce to you few libraries. Maybe you already using it, you are already aware of it, yet to use it, or maybe you are completely new to it. Regardless, after this session, you all are aware of it, and you can make use of it. First one is DataFaker, which is a continuation of JavaFaker. It's a fork of JavaFaker. And there was a nice talk in the morning from Elias. And a very nice documentation. The API is really simple to start with. And there are, as we speak, I think there are 250 providers like name, address, finance, so on. And then if there is a specific need that you have, you can create your own provider. A very nice documentation. You can extend streams, collections, and if you see, you can generate the collections with the length that you want, etc. This is, I think I took this 240 a few days ago, if I'm not wrong, so almost 250 data providers. But what happens when you are testing, let's say, an API, a real-looking API, a transaction API, which has 50, 75, 100 input parameters in the request? What happens if you do not care in filling up all those 50 parameters? You are, let's say, a transaction order. You are only looking for some fields like account ID, amount. You don't care for the rest of it. Instancio is a library that helps you do that. What it does is, it creates random data. The API looks simple, but then it fills up with random data, and then it gives you the possibility to customize special needs that you have. One nice thing is at the end, it follows the JSR 380 bin validation, so it doesn't create false positives. It follows, if you have bin validations, it follows it. Java reflections it uses, goes through the entire node structure. By default, 8 is the node depth, but then you can customize. Very simple API. First line, I do create instantiation of user, then I'm doing customization, right? Length of 10, integer from a range, etc. The website, the portal, has very good documentation, and there is no point that in a short talk, I talk about the possibilities. Please go through if you need special needs or customizations. So far, we have talked about randomness with two libraries, but we still need to cover repetition and corner cases. And for that, I did a show of hand in the beginning. So property-based testing, that's what I want to introduce you with. Some of you are aware of it, some of you are not aware of it, but again, after this session, if it is a concept new, you can leave this room knowing what property-based testing is. If you are not aware of it, you can start use of it. It's super powerful. Properties are rules or claims of functions that it claims to be true. Let's take some example. So for a reverse function, I would say one property is that if you reverse the string 2 times, you get back the original string. You can think of another property as If you take the first, the first item after reversal becomes the last item, and so on. Same for sorting. The property would be, even after sorting, all the elements are present in the sorting, in the result array. Sorting, reversal are trivial. These are not from like the enterprise application you are working on, right? So for more complex use cases, it could be the business rules, it could be the idempotent nature of the functions or methods. It could be a lot of the time we do in our APIs serialization, deserialization. Mapper, mapstruct we use, right? To DTO to entity and so on, vice versa. Invariants, we do sanitization of strings. We also do post condition. What could be the example of post condition? Let's say you are using a user with a user ID in the database. The user ID is not present. Post condition would be that it creates a user if it doesn't exist. It updates if it exists. So those would be the post conditions. And you can define the methods, you can define the properties based on these business domain areas. Show of hands, we did already. I'm not going to go again, but a quick look. QuickCheck was the first library that was created for property-based testing. And then Hypothesis, Scala, which is matured enough, followed similar API, similar structure. And Jqwik, if you're Kotlin, it's also available for you. If you're a Java developer, it's also available. Jqwik is developed, designed by an engineer from Germany. His name is Johannes Link. He was working with J-Unit core team, and later on he designed this. The randomness that it creates has two additional benefits, very crucial. It creates the corner cases out of the box, and it adds repetition, 1,000 repetition by default. You can adjust that. And the most important thing I like, and you are going to love it as well, is shrinking. I'm going to talk about shrinking in a moment, but what property-based testing does, forget about the features, extensibility properties, you can find it out online. The one thing that I want to highlight is the property-based testing libraries tells you, you find your properties, let the data part be handled by the library itself. So removes fixtures and factories, right? One example, again, a trivial example, in the latest version of Jqwik, when it releases, you don't have to mention @ property. You can use it @test as you are used to with JUnit. I'm doing for all positives and for all uppercases. Those are boundaries or constraints. And output of these will tell you 1,000 repetition with 12 corner cases. And if you go one level deeper, with the report annotation, it tells you, if you pay attention to this, so the first string is so big, and the last one is empty, and something in between. Imagine you doing this by hand manually, right? So a lot of the work is taken away by the library itself. If the integer age has to be based on my domain needs, I can do customization. I can say between 0 and 100, and then I say shrink towards. What is shrinking? Those of you who are familiar with property-based testing probably would know. For others, I'll tell you with a simple example. So I have a reverse item function method, which has a bug. I call it a lazy bug, but it's a trivial one. It reverses the item, and I write properties for that. I write a property that I check item get first, same with item get last after reversal. And then I say for all non-empty integer lists. What I see is original sample, if you see, of course the test fails because there is a bug. And what you see as an output, the original sample is with a big array with large integers. But the minimum thing you need to identify the bug was 0, 0, 1. So the library does a wonderful thing to tell you exactly, narrow it down to the point where the failure is. This is a very trivial example, but imagine this for a more complex business domain. As I said, at the moment, it's on a POC incubation, but Jqwik, Johannes is working on or proposed a new version, Jqwik 2, and it's going to have even better APIs. It's going to have even more smarter randomness, and the best part is it's going to have support for Spring Boot, and test containers. Now, as I promised, I'll be doing a comparison as well. It's quite natural that one library will not solve all the problems. You have different use cases. Example-based testing is still valid. We have been doing this for a long time for a reason. And the reason is it's simple, it's quick. It's good for regression tests, end-to-end tests, we call it. DataFaker, it's realistic, fake data. If you want to create a demo application, super. Locale specific. Instancio, as I said, large objects, complex large objects. And Jqwik is something that gives you the randomness, repetition, and corner cases. So with this, I want to wrap it up, and thank you for your attention.